Okay, now we're recording again. Um, okay. Y equals mx plus b. M's the slope, b is your y-intercept. This is your standard form. And generally, it's the simplest form. Picture. Your y-intercept is here. You have a rise, a run, and a slope of any fundamental triangle. Okay, so it doesn't matter what fundamental triangle you make, because the slope of the whole line is always the same. So if you have a line with a point x1, y1, point x2, y2, your rise is the change in your y coordinate. Boy, I'll tell you. Let's see if I can get that written halfway decently. Y2 minus y1, and your run would then equal x2 minus x1, so that the slope is going to be leave myself room to write that clearly. But it's y2 minus y1 over x2 minus x1, and we all know that. Okay, so we know x1, y1, and x2, y2. We can express the equation in different ways. deciding which way I want to do it. First of all, y minus y1, well, I want to write that differently. Okay, if we know this, then we know that y minus y1 over x minus x1 is equal to the slope, where xy is on the graph. So that the slope from y1 to, well, the slope between y1 and xy is y minus y1 over x minus x1. So we could also then write x1, y1 here. Having a bad time getting things spaced out right. Since the slope between any 2 points of the graph is always the same, then the slope from x1, y1 to any point xy is, well, you run as x minus x1, you rise as y minus y1. And here's your slope. So since this equals your slope, and if you know x1, y1, and x2, y2, this equals your slope, this is the same as this. Now, that's the easiest way to remember the equation in terms of real understanding of what it means. Now, you can use the equation, you can memorize the equation without understanding what it means. You can still get the right stuff, but this is much easier to remember. You're just doing the rise divided by the run here, rise divided by the run here, and this rearranges. And you can multiply both sides of this equation by x minus x1 to get y2 minus y1 over x2 minus x1 times x2 times x minus x1 on the right side, and the x minus x1 divides out on the left side, and you end up with this formula that people tend to remember and tend to use right, but not to really understand. Okay. You understand it by understanding that this slope has to equal this slope. So whether you want to really understand it or not, as long as you can use it, it's going to be okay. You can choose whether you want to go to the trouble of really understanding, and for some people that's more difficult than others. And for many people, it's much easier to remember the formula than it is to understand it. Okay. So we have somebody else that made it. Give it a minute. Hannah, let me know if you can hear me. Put some reply or put something into chat. Either way. Let me know you're there so we can talk to you. And put that into chat. We're going to pause here for a second, the recording. Good. Now, what we just did is we talked about equations of straight lines. You have the slope intercept form y equals mx plus b. That's your standard slope intercept form. If you have a straight line, then you can do a fundamental triangle between any 2 points, and it will always have the same slope. The slope of any fundamental triangle between 2 points is the same, and that is your m. It follows that if we have 2 points, x1, y1, and x2, y2, well, the rise is how much the y changes from here to here. That'll be, and the run is x2 minus x1, this displacement here. So the slope is y2 minus y1 over x2 minus x1. It also follows that if xy is any point on the line, then we could do the fundamental triangle between x1, y1, and xy and get an expression for the slope, y minus y1 over x minus x1. So if we know x1, y1, and x2, y2, we can write an equation. The equation is this slope equals this slope. So if I note that y minus y1 over x minus x1 is the slope, and we know that this is the slope already, then y minus y1 over x minus x1 has to equal y2 minus y1 over x2 minus x1. And if we multiply both sides by x minus x1, then on the left, the x minus x1 will divide out. And on the right, we'll just have x minus x1 times this expression. We get this, which is your standard 2-point equation for the straight line. Okay, so there we have it. Now, you have problems in your assignment, your upcoming assignment. At least one student has completed quite a bit of that assignment, which is really good to see. Okay. So let's say we have a straight line. Here. And we can identify its X and Y intercepts. So this is the point, let's say, A0. I hesitate to use A there because sometimes that's used for slope. But this A0 and 0B. Okay, well, we can get the equation of this line rather easily. Slope equals what? I'm just using these 2 points. You can draw a triangle here. And the run is A minus 0, because of course X goes from 0 to A. And the rise is what? Well, Y is going from B to 0. Now you got to be careful. I instructed you earlier, whenever you do a fundamental triangle, you really want to have some arrows that go from one point to the next along 2 different paths. So if we start at this point and go directly, there's our arrow. If we want to start at this point and go to here, following the legs, well, here are the 2 arrows. This is very important because now we see that our rise goes from, well, the Y coordinate goes from B to 0. So the rise is having trouble writing the thing I'm going to write next before I write the thing that precedes it. You've seen me do that before. Sure, you'll see me do it again. Okay, the rise is what? Well, you subtract where you start from where you end. We've talked about that, make sure we understand that. So we start here at Y coordinate B and end at Y coordinate 0. So we'd subtract where we start, which is B, from where we end, which is 0. The rise is 0 minus B. So that the slope is zero minus B over A minus 0, which is negative B over A. So slope is negative B over A. And the y-intercept is B, or if you want the point 0 B. As an example, let's say out here is 4, and up here on the y-axis is 6. So this is the point 4, 0. And this is the point 0, 6. So now we don't follow this as a formula. This is just generally how we do it. We sketch ourselves a fundamental triangle. And we note that if we go this way, the run is 4. And the rise to get from here down to here, the displacement is 6 units downward. That's negative 6. So the slope is -3/2 when it's reduced. And the slope is 3/2. So if you see a graph in the homework, if it has a y and an x-intercept, I mean, it does, but the y and x, one of the intercepts might not even be showing, then you can do this. Okay. Now, what if you have the question asks you to do the straight line through the point let's say 2, 3, and 8, -1. I would recommend that you draw a picture to reinforce what's going on. Instead of doing the most expedient thing and trying to look at the answers and figure out which one is right. And of course, your problem might not even give you a multiple choice. It might actually ask you to enter the thing. But anyhow, your straight line through 2, 3, and 8, -1, we can depict the situation. Okay, so let's just say here's 2, here's 3, so here's the point 2, 3. And then way out here someplace, this isn't to scale, 8 should be a little further out. But we'll say that 8, -1 is here. So here's your point, 8, -1. Well, then we can sketch the line. And we can use the fundamental triangle to calculate the slope. Okay, so I'll do a fundamental triangle down here. And we see that the run is 6, go in this direction, and the rise is -3. Pretty grotesque looking 3, but the chalk, you know. Okay, so we have -3, we have 6, and the slope is then -1/2. -3 divided by 6 gives you -1/2. So we get that very quickly. Okay, then I really recommend you do a picture. You could draw the same line. Pictures are harder to forget than formulas. So now we have, let's just say we have the point 2, 3. Let's just put a point XY. We can put a point XY anywhere because XY is going to stand for any point in the line. So here's the point XY. And now we can do a fundamental triangle. And the run is going to go from X to 3. And it's 3 minus X. And that's wrong, it's 2, goes from X to 2, 2 minus X. And it's going to then be, rise is going to be 3 minus Y. And your slope is going to be chalk isn't writing very well, but I'm just not using it very well. Slope's got to be 3 minus y over 2 minus x. So now the equation is 3 minus y over 2 minus x equals negative 1/2. And that's a perfectly good equation. We've got to solve this for y if we want to put the slope into slope-intercept form. Don't have room to solve it here. So I'm going to move this over. So now we know equation of line through 2, 3, and 8, negative 1. Is y minus 3, or, sorry, 3 minus y over 2 minus x equals negative 1/2. Solve for y. You get 3 minus y over 2 minus x multiplied by 2 minus x over 1 equals negative 1/2 of 2 minus x over 1. Now what I've done here is I've multiplied by 2 minus x. And I've done it carefully in all its gory detail. And I'm going to follow gory detail through the whole rearrangement. Okay. In other words, 2 minus x is the same as 2 minus x over 1. I use 2 minus x over 1 on both sides because I've got a numerator and denominator on both sides, and people tend to do anything involving fractions by superstition rather than rules. I'm going to do the rules. Okay. So the rule is we can multiply numerators and we can multiply denominators. So now we get 3 minus y times 2 minus x over 2 minus x. Instead of crossing things out, because people will cancel incorrectly if there's any opportunity to do so. If you don't know the rules for cancellation very, very well, better off doing this. Okay, so 1 times 2 minus x is 2 minus x. 2 times 1 is 2, and the negative sign goes out in front. Now, this isn't totally familiar to you because you're used to crossing things out. If you're going to cross things out, make sure you do it right, because I'm not sympathetic at all when I'm grading and there's an incorrect cancellation. Okay, trying to show you why things work the way they do. And I'm not going to even teach the rules of cancellation. It's pre-algebra. And we just don't have time to do it. So either know those rules or be able to work it out. Okay, so we do this. Well, we can rearrange this as 3 minus y over 1 times 2 minus x over 2 minus x. And then a negative of 2 minus x is negative 2 plus x. We can do this. Now, 2 minus x divided by 2 minus x is 1. So this is 3 minus y over 1 times 1 And this is -1 plus x over 2. Now, people will, speaking of incorrect cancellation, want to cross this out and cross this out, and then just write, well, this is just x. Okay, I see it all the time. And when I do a pre-test and pre-calculus courses, 95% of students will do that. Just given this expression, 95% of students will cross the 2's out, ignore the negative sign, and say the answer is x, which is why I don't acknowledge cancellation. Okay. Now, 3 minus y over 1 is 3 minus y. And if we multiply by 1, we're still going to get 3 minus y. So we get this. Then we add 3, subtract 3 from both sides. I'm writing out the whole blame thing. Not adding y, I'm adding 3. And then, I'm not adding 3. Talk about cancellation, then I do something dumb like that. But there it is. Okay. And then 3 minus 3 is 0. So that does leave us with negative y. And this is x over 2 minus 4. Now we've got to multiply both sides by -1. So we get y equals negative x over 2 plus 4. So there's a lot of algebra in doing this. You need to understand algebra at this level in order to do it reliably without making mistakes. If you want to shortcut it, go ahead, but make sure you know the rules. So we're just basically solving this equation for y. We multiply both sides by 2 minus x. And here are the details. It brings us down to here. Okay, so here are the details of why it leads to this. Then solve for y. Okay, that's the process. Then the last step is we check. You know what to check? Remember, we started with the 0.23 and the 0.8 negative 1. Okay, well, we plug that in. 3 should equal negative 2 over 2 plus 4. Okay, just plugging in 2 for x and 3 for y, and we get this. So 3 is then negative 1 plus 4. So 3 equals 3. Put a check mark there. And then we check the 0.8 negative 1. Again, x is 8, y is negative 1. So we get negative 1 equals a negative of 8 over 2 plus 4. Yep. It's not plus 4, it's minus 4. No, it isn't. Doesn't check. Means in all this algebra I did, I must have done something wrong. It's never happened before. Oh, I don't know what to make of this. Actually, it has. Okay, so just pretending I've made an error. Let's see how that works. Now, seriously, there shouldn't be an error here. Slope is negative 1/2. Y-intercept should definitely be 4. Uh-oh. Yep, I made a mistake. I could throw a couple of bad words into that sequence of question marks and exclamation points. But, I was pretty careless here. Okay. If we go back here, now we see that when I said my rise was negative 3 here, well, the rise isn't negative 3. We're going from 3 down to negative 1. The rise is negative 4. Okay. So there's an error because I had the incorrect rise in my very first step. If I had the correct rise, it'd be negative 4, and the slope would be negative 2/3, and then everything would check out at the end. We have an error. Find it. Okay. The original rise is negative 4, not negative 3. So now we got to go back and correct the whole thing, but I'm not going to do that. A lot of times I will intentionally make a mistake like this so I can illustrate the process. This time I just made a bonehead mistake right here and went on with it. And it's a good thing I checked because now I can go back and it's pretty easy to fix it. Okay, if this is negative 2/3, then we have negative 2/3 here. And the negative 2/3 will carry through. And we'll end up with 2/3 here, but then that'll multiply some stuff and it's going to come out just a little different. Okay, so there's the process if you know 2 points. Okay, well, that should give you some techniques, some ideas for solving problems on the exam. Not on the exam, I'm sorry, on the homework. A couple of other things, and I'm going to go ahead and do them. You are welcome to stick around. But if you have someplace you have to go, or for some reason have to leave, then please feel free to do so. But since we started at least 20 minutes late, I want to go ahead and do a couple more things so you'll have it on video. Now, I've had trouble last week, tremendous trouble, technically, with being able to post videos. They're all posted now, but they're posted very late. My computer was getting locked up, which happened today as well. Might be my ISP, it might be Zoom, but I do have an alternative now because I can. Now, the problem basically was my ISP doesn't appear to be giving me the upload and download speeds, nothing even close to it that it's supposed to. So downloading one of these Zoom files was taking several hours in many cases. And the files are less than a gigabyte, which means that I was getting just a tiny fraction of what I'm paying for. So I'm going to take that up with my ISP. But in the meantime, our tech support, which is wonderful at the college, got me a connection to my on-campus computers. And when I do it with an on-campus computer, even the biggest Zoom file downloads in seconds, as opposed to hours. And I've got a pretty fast connection here, I'm supposed to. Something's slowing it down. Anyhow, as a result of all that, things just melted down completely last week. And it took me until sometime in the weekend to get everything posted. Okay. I didn't need to be recording those comments, but I did. Shouldn't be a problem now. So you should have, the whole point of all that is you should have the file linked into the assignments page for this date by sometime not too, within the next hour or two, assuming everything works. Okay. No, I'm not going to do that. I'm going to take the time. Okay. Now, what you do if you see a graph, maybe it looks something like this. Where, let's say you can identify these points. You can identify this point as being -2, -1, because you have a grid. You can see where it is. And this point is maybe -6, -5. And this point is -2, 2. And this point is 2, 2. And this point up here is 2, 5. And this point here is, that's 2, that's maybe 5, -2. A lot of 2's in there, but it's okay. Okay, the equation. Well, I'm not going to go through all the details, but this line segment has a slope. If we go from this point to this point, we're going from y equals -5 to -1. That's +4. Over from -6 to -2. Well, that's also +4. That equals 1. So that y minus y1 over x minus x1 is equal to the slope. So you have y minus call this y1. That's our x1, y1. So your y minus y1 for any point y on here, you can do the fundamental triangle and everything. Don't have to, you can use it as a formula, but good idea to think about it. And then you get y minus, well, let's see, y1's negative 5 over x minus negative 6 equals 1. So that y plus 5 over x plus 6 equals 1. Again, you should think through the details of this. You get y plus 5 equals x plus 6. So that y equals x plus 1. And you check that. If y is negative 5 and x is negative 6, negative 6 plus 1 is negative 5, so the equation works. If y is negative 1 and x is negative 2, negative 1 equals negative 2 plus 1, negative 2 plus 1 is negative 1, so it checks out. So I'm just going to put in here, you really should check, because it reinforces everything you're doing. Takes a little time, but not that long, and it's worth it. Okay, so we know that the equation here is y equals x plus 1. So I'm going to write that. Up here, well, this is horizontal line, part of the horizontal line, x equals 2. X is 2 here, x is 2 here. I'm sorry, y equals 2. Y is 2 here, y is 2 here. So this is the line. Y equals 2. Up here, running through this whole process a little more quickly.
Excuse me, Professor?
Yes.
Is there anything you can do with your camera, because it's going in and out of focus and it's very hard to see? Very hard.
Nothing I can do about that,
Okay.
except maybe stop moving. And I'm sorry about that, but this is the best camera. Yeah, it's the only camera I've found for under a couple $100 that gives us the full resolution we can get through through Zoom. And I'm not willing to spend more money than that, and the college is not willing to spend more money than that to experiment with other cameras that are probably going to do the same thing. So unfortunately, it's a great camera, but I've noticed that that does happen. I usually don't catch it happening. So usually it happens when I look away and then look back. It does it behind my back. I'm not sure what to do about it. I am aware of it. Okay, anyhow, -2 minus 5. Okay, slope here. This -2 minus 5 is the rise. 5 minus 2 is the run. So that's -7/3. Then you can get y minus, let's say 5 over x minus 2 equals -7/3. So y minus 5 is -7/3 of x minus 2. Now in this case, since I have a denominator here, algebraically it gets much simpler if I just multiply both sides by 3. So if I multiply 3 times y minus 5 equals 3 times -7/3 times x minus 2, I get 3y minus 15. And then this 3 can be rearranged, do the fractions and stuff to where it's divided by this 3, so it becomes 1. And we get negative 7 times x minus 2. And this equation is much easier to work with than an equation with fractions. So we get, I'll do an extra step here. We get 3y minus 15 equals negative 7x plus 14. We add 15 to both sides, we get 3y equals negative 7x plus 29. And then we divide both sides by y by 3. And we get y equals negative 7/3 x plus 29/3. And then we check. I'm not going to write out the check, but if we substitute 2 for y, or 2 for x, we should get y equals 5. Well, if we substitute 2 for x, it gives us negative 14/3, which we add to 29/3, giving us 15/3. Negative 14 and 29 is 15, and 15/3 is 5, so we have this point. If we put in negative 2 for x, then we get a 14 and a 29. Sorry, put in 5 for x, get negative 35/3 and 29/3. Negative 35 and 29 is negative 6, and negative 6/3 is negative 2. So if you plug the numbers in and do the fractions, it's pretty straightforward. Okay, let me just ask you, did the camera fade in and out again?
Yeah, it's very blurry. I can't read anything.
I'm sorry?
It's very blurry. I cannot read anything.
I'm looking at the screen here, and it's not blurry at all. So I'm going to have to check.
What about
It's not that I don't believe you, but I'm going to have to check the video to see. But there's no evidence here of a blur. So given all the technical problems that we've been having, nothing surprises me. So hopefully when you see the video, it'll be clear. Okay. So anyhow, now we have an equation for this line, which is y equals negative 7/3 x plus 29/3. So how do we write the function? Uh-oh, I don't have the board behind here. Okay, I should be able to flip something. Yeah. So the equation of the graph is, well, y can equal any of these 3 expressions. So it can equal x plus 1, or it can equal 2, or it can equal negative 7/3 plus 29/3. Now, where does it equal x plus 1? Well, it equals x plus 1 from negative 6 to negative 2, including, because these points have solid dots on them, at negative 6 and negative 2. So we can say, well, that's true for negative 6 less or equal to x, less than or equal to -2. And then what? Well, then from -2 up to +2, x values from -2 to +2, it's equal to 2, but not at x equals -2. So this is so for x greater than -2, but not equal to -2, but also for x equal to 2. Here, we probably ought to put the x in here. We didn't have it before, so now it says -7/3 x plus 29/3. It equals, it's this, but it might be a little hard to read because I didn't write the x and had to slide it in there. In any case, from x equals 2 to x equals 5. So from 2, now not at 2, so we have to say 2 less than x less than or equal to 5. And there is the equation. Okay, well, that's pretty much what I planned to do for today. And we started about 20 minutes late. We'll end about 20 minutes late. Any questions? Anything you'd like me to do, because I'm glad to do it. Except fix the camera. I don't know what to do about that. I have to check it out and maybe get some technical assistance. But again, I don't see any problem with the camera. Let's test one thing. Is it still blurry?
Yes.
Okay. I'm going to just switch cameras, which will just take a second if the thing will come up. Now this should change in just a minute. Coming up. Computer's not acting right. Okay. Now, is it any more or less blurry?
I'd say it's more blurry.
Is what?
More blurry.
It is way more blurry.
The what?
It's very much more blurry.
Yeah, well, it's a worse camera. It's a camera that came with the computer. It's actually a pretty good computer. I don't know why they put a cheap camera in it. Let me bring the video back to where it should be. I'm going to stop the recording because now, well, let's see what happens. I'm going to keep this recording. Back to the better camera. Now what?
It's still blurry.
Still blurry?
Yeah.
Less so?
It's less than
Okay,
it was,
I'm
but
hearing
it's still unreadable.
Again? Okay, well, I'll be able to look and see if this really happens on the video. I hope it won't. But I'm saying what I should be saying. It's very clear. So hopefully that'll be the case with the video. Has that been a